Welcome, everybody. We are back and we are going to be working on Module 2 today, but I wanted to do a little bit of cleanup on Module 1 and talk about this little entry about problem solving. And I think I've mentioned, already to all of you that I think that the essence of working in information technology in general and in programming really is at the heart of it, problem solving, and that is really what we do as a profession. And you know what, there are techniques for it, which is why computer programming is such a thing, right? There, and it's very learnable, and there are a bunch of different ways to proceed with it, but some of them are very simplistic and logical and built upon tried and true methods that a lot of us in the field have like vetted for years and years. um, as you look at this example, they give you a few different scenarios. And what they're having you do is look at really something that is really prevalent in all of information technology. And it's called a systems based solution. And when we look at this concept of a system is basically comprised of some sort of an input, a process that happens, and then some sort of an output. This can be applied to a lot of different scenarios. And what they've done here, on this page is they've put together a few different scenarios to demonstrate what some inputs are, what the processes are, and what the outputs are. I'll give you a completely different scenario than is on this page, and one that I often use when I teach my classes. I think of manufacturing as a system as well. Think about if I owned a company that created paper, and I owned a factory that created paper. What would be my inputs for my factory? Well, I would take logs from the forest, or maybe even scrap, lumber, the sawdust or whatever from the sawing floor, whatever, any lumber product, and I would bring that in as my input. Raw material starts as a log. From there, whatever my process is inside the factory, where I, cut it up, munch it up, add chemicals to it, flatten it out, process it, flatten it, make it, bleach it probably to make it white, package it up and put it into reams, and then put it on a pallet. And then ultimately the output is paper, regardless of what the processes are in the middle. I'm inputting logs, I'm processing those logs, my output is paper. That entire collection of activities is the system, and there are mechanisms that affect the system from the external world, like the supply of logs, for example. And there's also control and feedback mechanisms, like, for example, the demand of the product from our, people who purchase the product. One interesting thing happened with information technology is when we got computers and we started doing things on screen. And for example, like, we never asked students to turn in something on paper, right? You don't write your code and turn in a piece of paper. We thought, hey, paper would go away, right? But what happened with computers coming into the mix, people started to print everything, you know what? And that trend hasn't changed. People print a lot more than they used to, believe it or not. All right, so a couple of interesting scenarios here. I always like this as a scenario for problem solving, which is a recipe. And it sounds really dumb as a correlation to problem solving, but it has a really direct connection to programming in a number of different ways. If I'm to make a sandwich, right, I'm going to need some stuff to make it. So I do need some inputs, right? Okay, so what do I need? I need some bread, some sort of peanut butter, some sort of jelly. Okay, maybe a plate, maybe a knife or a spoon, or, whatever you're using to spread the peanut butter around. Maybe you're using your fingers, I don't know. But you need inputs. The correlation to programming often is that might be our data that we're feeding in. Then there's the step by step. So this is where it ties into programming directly. We might have data as an input or objects as an input, but we have to have a sequence of steps. So for example, I wouldn't want to put my knife into the peanut butter jar and get it on the knife and then not have the bread sitting there waiting to receive the peanut butter. Or are you a jelly first person and then you do peanut butter? Do you use a separate knife for your jelly and a separate knife for your peanut butter? I mean, there's so many variables when you really stop and think about it. But whatever the procedure is that works for you, there's a sequence. My sequence for something like that might be, yeah, pull out the bread, peanut butter first. That's what I would do, right? I don't know why. Maybe it's because of the name, peanut butter and jelly, as opposed to jelly and peanut butter. So that's how my brain works. I do the peanut butter first, then I add the jelly, then I put the two pieces of bread together. I might do a diagonal cut, or when the kids were young, I'd cut it into 4 pieces so they could have little easy pieces to eat. And then you go ahead and consume, right? What is the output? Well, you have a sandwich that you can eat. The other example here, and this is a real classic programming problem, is converting Fahrenheit to Celsius or vice versa. So what do you need as an input for that? Well, whatever the temperature is in Fahrenheit, then there's a formula. Okay, we assume the formula is correct. And then, so that processes the information. You can see the 77 here, right? So if I was given this, I might set a variable, set Fahrenheit equals 77. And then in the code, this would say Fahrenheit, not 77. I wouldn't hard code it. Right? So that's what I was trying to push before. You do the math and then you get an output which tells you the correct value for what you're looking for. All right. Another example. And this one is, they're using Mario as an example. User taps on the screen. And is it a short press or a long press? And if you've ever played that game, you get a short jump or a long jump, depending on the length of the press, right? So there is a direct correlation, right, to programming, but it also can correlate to physical real world problems as well. And I always like the recipe as an example. And I often have my students over at Gateway have a recipe be their first coding assignment, right? And they're like, what am I writing a recipe for? And I try to explain to them, well, I have a problem. My problem is I lack chocolate chip cookies. So I need to create some. I can't go to the store because let's say my car's broke down, but I do have all the ingredients. So I gather all my inputs, I go through the sequential process, and then my output is chocolate chip cookies, which I can enjoy with a glass of milk. And how wonderful is that? So just a correlation, right, in terms of how that works. Now, when we start to look at like, let's say a recipe, and students go, why a recipe? Because when we create recipes, we write them down. And you know what? Sometimes recipes are really simple and you remember them. So for example, last night I made a batch of waffles. That was we had breakfast for dinner and I made waffles. And I thought to myself, hey, I know this recipe by heart because I've made it so many times. I know how many eggs to use, how much flour to use, and in many cases, I'm not even kind of measuring. I just kind of eye it up because I know what works and it works, right? But if you've never done it before, having that recipe is huge in getting it right because it's got the procedure, like, you put wet ingredients together first and then the dry ingredients get added, but you might pre-combine all the dry ingredients before you add them to the wet ingredient. It's like really goofy stuff like that. And if you ever talk to master waffle makers, they'll separate their egg whites from their yolks and make the egg whites really fluffy and then add the yolks. And then I'll add, it's like there's a process. And then if you've ever had the waffles, you go, man, these are really good waffles. And you're like, well, that's why, right? Because they took extra care in the precision steps that other people, just throw everything in there and mix it, right? Some people do that and they're not quite as good, right? There's sometimes a reason for why the steps exist in a certain order. When we start to take steps and we start to list them or write them down, what makes a lot of sense is to pseudocode. And pseudocode is basically the process of gathering information to put the steps together in the right way to make the program work, but doing it in plain English without worrying about the syntax of a programming language. So for example, if they have this little example here, if you want to write a program that takes two numbers from a user, adds them together, and then outputs the sum, an algorithm for the program might be ask the user for the first number, store the number. It's kind of what I was hoping you do in that exercise, by the way, right? Ask the user for a second number, store the second number. And now some of you are going, do I really need to say each step like that separately? Yes, you do. You really need to think about what is really happening on a minute level in order to be able to process it accurately on a code level, because the code needs the detail. You can't omit the detail and have it be correct. And then finally, it says add the first number to the second number and store the sum, output the sum. Now, this is in plain English, but it is pseudocode. There's nothing here that declares a variable or a data type or anything like that. We're speaking in very general terms, but this is a recipe for succeeding at adding two numbers together that a user gives you and putting it back on the screen, right? And it's repeatable. So we call this an algorithm. So it's a pre-designed solution to a problem. And given an accurate algorithm, we can then apply any numbers to this algorithm and get the correct answer in the correct way consistently. So an algorithm, and that's really an important word, is a predefined series of steps that contain the solution to a problem that will allow for various types of input and will work in every scenario. Kind of an interesting thought, right? So it's one of those words that you hear, like you'll watch Star Trek and, Commander Data will say, Captain, I have an algorithm for computing the distance to the next star system or whatever, right? And, you have to believe him, right? Because he probably sat down and figured it out in his, computer brain or whatever. Now, another thing that you might look at is, for example, they have the goofy little Mario example here. So it says you might break down the events of Mario Run as follows. Wait for the user event. What's the user event? Some sort of interaction on the screen. In this case, a screen press. So if the input is a screen press and it's less than or equal to a second, we do a short jump. If it's a long press greater than a second, then we do a really long jump and we indicate it like this. Now you notice they are using if statements here, right? So we're checking for conditional logic. And one thing that I think is actually missing from this little screen here, and I'm just going to type these up on the screen, is we have these logical ways to solve problems. One is sequence, step by step. The other is selection or decisions, which is what we're looking at tonight. So you get to basically a fork in the road, because with the Mario thing, we're checking to see how long is that key press. Is it short or is it long? And depending on which one it is, we take a different course of action, right? And then the other one is repetition, which we haven't gotten to yet, but we will eventually reach this as a major concept. Whenever we're working with a system solution and designing an algorithm, it is these three tools that we use to solve any logical problem in a system solution, right? So like, and this is vetted from mathematics, by the way, and logic, so that's kind of where it branches from. So we can solve any problem by going step by step, by making a choice, and by repeating actions. For example, these could apply to many different scenarios. So if I was making my peanut butter and jelly, and then, let's say I got my bread going, I got my peanut butter on there, and then all of a sudden it's like, uh-oh, I don't have any jelly. And I'm not going to have a plain peanut butter sandwich. What do I do? You might have a selection to make. If there's no jelly, use honey. That's my fallback, right? So if I'm out of jelly, I'll put honey on my peanut butter sandwich. Right? The other thing that I might do is when I'm putting the peanut butter on the bread, I might dip the knife once and spread some on, but that's not enough. Okay, it's not enough. Let's do it again. Let's keep going until the whole bread is covered. That's a repetition, right? So just kind of show you how that can apply to just about any scenario. If working out a problem verbally is not ideal for you, then you also have the option of creating graphics that help you. In the business world, we've used flow charting for a really long time, right? And if you guys have ever studied any business topics at all, this is a really big thing. And like if you go on to study business administration or something like that, because businesses usually operate with processes in place. You can use the factory example if you want. And there's certain shapes and formats that we use in flowcharting that also relate to the same kind of thing that we do in pseudocoding. So I could take whatever thing that problem I'm trying to solve and convert it into images step by step, just like I would with words. So for example, they're using these shapes. Usually a rectangular shape is a background process. This one doesn't really have a very good flow to it. If for example, if I was going to prompt a user, I would use the parallelogram, which is the input output shape. So it's getting from the screen and putting to the screen. So I might start a program by saying, how many peanut butter sandwiches do you want? The user enters a number. And then I might, have a step-by-step in a series of square boxes that are like, grab the bread, grab the peanut butter, grab the jelly, spread them around, put them together and serve, right? But then maybe there's a little thing here. You go to grab the jelly and there's a question, is there any jelly left? Yes, use the jelly. No, use the honey, or I guess have a plain peanut butter sandwich. But flowcharting can be a really useful tool. I showed you like a really brief example from my Java class, like how I was doing a little bit of flowcharting, to help solve a problem. And flowcharting can get really, really complex. It depends on what you're trying to solve. As we're working through some of our slides today, there are some flowchart elements that we will look at that will show like the branching. So whenever we do decisions, by virtue of like an if statement, typically in programming, they respond in a true or false or yes or no fashion. And you see here, is there more to do? Yes, go up and do it. Is there more to do? No, then you just move on, right? And you follow the branch that takes you to where the logical output is. Smart programmers will always take complicated problems and either pseudocode them and or flowchart them first before they start writing code. Because I'll go back to that goofy example I had. You want to build a house, you don't run down to Menards and buy a bunch of 2x4s, a hammer and nails, and get busy, right? It helps to have a blueprint to work from. And that's really what problem solving is all about. Now, they do use a bunch of different shapes here, and I'm not like really giving you any assignments on creating flowcharts. You should be thankful of that, by the way. I do, when I teach Python over at Gateway, I make my students do that, by the way, because I do think it's important that they get at least a little flavor of it, even though it's very simplistic. But I will tell you that if you've ever seen a professional programmer work, when the problem is really complex and it's really hard to kind of like ideate just in your brain, it really helps a lot to have a visual, either with words or with a picture. As goofy as that sounds, it helps a lot. And it will also show you what things you've created and what's things you still need to create in the program. Because just because you have all these separate pieces of a program doesn't mean you have to create them in the sequence that they're listed. You could kind of pick and choose. And my typical technique for writing a program is I create the easiest parts first and then figure out the challenging logic parts later and then plug them in. And then, the easy parts are already there and boom, you have a program. That's my technique. People do work in different ways though. Any questions on this at all? I think you will find though, and you guys should mark my words, is when you start moving on to more advanced classes and you have to start writing more complicated code that gets you thinking about solving a problem, think about pseudocoding and flowcharting is really a helpful tool to help you get there. And think of it as a blueprint for what you're about to build. And that it really helps significantly. Now, what I'm going to do is I'm going to jump us over to module 2, and I'm going to start by looking at the study materials and just show you what we have posted here. I do have the slide deck all set to go. You guys can follow along or download your own copy if you wish. There's a couple external links here to W3 schools talk about switch statements and methods. And I think those are helpful, but those are not right now things. We're going to start with some basics first.
Are we in module 3 already?
Oh, you know what? No. Yeah. No, we are not in module 3. Thank you, Lena. I'm not really sure how that happened. Did I like over scroll? I think so. Yeah. All right. So some of these things here we'll look at as we kind of go. But for right now, we're going to go right through the PowerPoint, and then we'll take a look at those auxiliary materials later. All right, folks. Here's our general agenda for tonight. These are the things that we hope to get through in this module, actually. So hopefully we can get through most of this tonight. We'll see how it goes. Lot to learn here. This is really talking about that second structure of problem solving, which is selection or decision making. And large portion of what we do is focused on if statements and their variants. We will also look at relational operators and logical operators. We've done a little bit of that already, but now we're going to dig in a little bit deeper and see how they're used in the real world. Let's move on to a couple of these slides here because they're setting up a scenario to have you think about why this technique is important. All right, so it says you've been hired by PetMart to work in their cat food department, making customer recommendations, right? You can see we have 5 different cat foods that are available. It says you can only recommend one type of food per customers. What question do you ask, right? Now, interestingly, we have a kitten in the household right now. So we've been buying kitten food, which is different than regular cat food, by the way. It's like higher in protein and a bunch of other things. So we've been kind of going through the scenario. For our older cats, it's like, I don't know, whatever's on sale, that's what we get, that kind of thing. But if you're getting for a kitten, it's a little bit different. Or if you're getting it for an aging cat, it's a little bit different, right? You want to be appropriate to their health needs and concerns. So it says you can only recommend one type of food per customer. What questions do you ask? You see an illusion here at the bottom, right? So they say this one is only for cats under 2 years. This is for 10 or over. Adult cats, that's pretty vague. Indoor cats, or for overweight cats, right? The overweight bag should be really small, right? Joke. All right, so PetMart is so happy to have you on board. You're going to write an app for them, right? Because that's what you do when you're working retail. Absolutely. You know what? I know that sounds really goofy, but you know what? Might be a thing. Might be a thing. All right, so let's take a look at how that might operate. So what we're going to look at is this thing called the if statement. And if is one of these words we use in the English language. And, so here I'm going to give you an example of an if statement to start with. If you have $20 or more, we can order pizza tonight. Otherwise, I'm going to make mac and cheese. It's one of my classic little if statement examples. So I'm setting up basically criteria for how I'm going to branch in a program. So take a look at this slide, and it says, until now, our program starts at the beginning, it runs until the end, and every line in the program gets executed sequentially, right? When we have an algorithm set up, it says algorithms require code to execute under only certain circumstances. And if we're hitting every line, we're not operating under that paradigm, all right? So if we want to do that, we need to have some sort of a decision structure. So enter the flow chart, right? Because it's an illustration. Is it cold outside? Yes, wear a coat. So I found myself like digging up my hat, my gloves, and my winter coat. to go out in the snow to walk the dog just a little while ago, and it was shocking, right? Because up until now, it's just been light jacket and whatever, maybe no jacket, just go. See, I even got my flannel on. I was so cold. And it says the simplest decision structure performs an action if a condition is true. So notice the question says, is it cold outside? The answer is true or yes, then you wear a coat. False, notice we're just bypassing it. We're not putting on a coat, right? So in a simple if statement, if there's a condition that's met, we will execute a statement or several statements. If it is false, we just skip over those statements. Okay. So it could be that we only do one action, or it could be that, this is my scenario right here. Is it cold outside? Yes. It's coat, hat, and gloves, all three. It wasn't just the coat. So that's a really good example. If it isn't cold outside, I wouldn't put on any of those. Why would I? No need. You just skip right over it. When it comes to writing the expression in code, it looks like this. So we use the keyword if, and then we, in parentheses following the keyword, we put in a Boolean expression. So we're going to learn all about these. But basically, it's a statement that can be evaluated to true or false, right? We wouldn't do math here necessarily. Well, we might, but we're not looking for, the result of a mathematical operation necessarily. We are looking for a logical question that you can only answer true or false to. And if the answer to this expression is true, then we execute whatever statements are inside the curly brackets. Okay. And what's interesting is if that expression, whatever it happens to be, is false, this will just be ignored. Those will not happen. That's a basic if statement. As we start to build those Boolean statements, here's where our operators come into play. These are called relational operators, meaning they look like the mathematical equivalents. And in some cases, they kind of are, right? Where we can do greater than or less than, or greater than or equal to, less than or equal to. I want you to notice here the special usage of a double equal sign on this, right? And the double equal sign is important in that it does not assign a value to a variable, but it's checking for equivalency. And I usually, tell my students, whenever you see a double equal sign, what it really means is this thing equivalent to this thing? Where the normal usage of a single equal sign when we're writing code is take whatever's on the right side of that equal sign and store it in the object on the left, usually a variable or a constant or something like that. There's also another relational operator that's kind of unique, and that is using the exclamation point, which is a negation of equals. So when we say exclamation equals, we're saying not equal to. 10 is not equal to 20. Is that true? Yes, it is true. It is not equal to 20. So whenever we see these, we will have to have two expressions on either side that will evaluate with that relational operator to either a true or false. So that's kind of like often the heart of our Boolean expressions. Now it says some of these operators are composed of two symbols instead of one. Now, if you think of how we do this in mathematics, like if you have the joyous pleasure of taking math classes at the same time as you're taking this course, which often happens, if I was to do a greater than or equal to in math, I would write it like this, right? You guys recognize that from like algebra class or whatever? And that's not how we do it on the keyboard because we don't have those symbols on the keyboard. So we use a combination of both of the operators in sequence. So we say greater than or equal to. The thing that's really important to note is there's no space there. Well, they're right next to each other, they're touching. And that's really the point of the slide. There's no space between the operators. If you put a space in there, then they're not relational operators any longer. They're just characters. Here's an example of how some of these might resolve, because when we start to write these if statements, we will have situations that are kind of similar to this. So let's take a really quick look at this chart. So if I have two numbers that are given to me, or like the program that you guys just wrote where you're asked to input a couple of numbers, you will be asked, is the length greater than the width? That would be the first. And notice how it reads. The open side of the greater sign means the thing on the left should be larger, whereas with the less than symbol, we start with the item that's expected to be smaller on the left, and the symbols are just reversed. And I think you guys already get this, but I sometimes have to reinforce it because I don't know, not everybody's an A student in math is a polite way to say it, right? So it doesn't hurt to reinforce. So greater than, length is greater than width, length is less than width. And really what we're asking with a statement like this is the length greater than width? And it's going to resolve to true or false. It cannot be both, right? And in this situation, the next two, where we add the equal sign to it, they can also be equal, but we're still generally looking for greater than or equal to width, right? And in this case, less than or equal to width. Finally, we go back to that double equal sign again, and we're checking to see, are they the same? Are they equivalent? If they're equivalent, then it's true. If they're not, then it's false. And then the negative version of that, which is not equal, and that's the one that usually messes up people's minds, right? Because like it's kind of like talking like double negatives in English. Are you not going to nowhere, know how, that kind of thing. And you got to be careful with how that's phrased and be really clear with your logic. But the exclamation point, generally speaking, when we put it in front of things, means not in programming. Now, they make a special point here talking about this little piece, because when we use the greater than or equal to or the less than and equal to, we have to remember that there is the possibility that the equal can fall into place. So you got to be really mindful of this. You can leverage this to your advantage or disadvantage. So you got to have your logic firmly in place. Is 5 less than or equal to 9? Well, that's true. Is 9 less than or equal to 9? That's also true, because it is equal. It's certainly not less than. If it was 8, it would work too. But since the equal sign's in there, 9's okay as well. See how that works? Right. So that's a really important thing. Right. All right. So now let's start to look at an example here, and then we'll try coding together, by the way. Let's look at this setup here. So we have an integer called grade. We've stored inside of it with a single equal sign, right? That's the single equal sign stores. It's an assignment character. We're storing 10 into the integer called grade. Now I'm running the if statement. And the if statement says, if grade is greater than or equal to 9, curly brackets, and then a statement. So what would happen in this case is, yes, the grade is greater than or equal to 9. So this evaluates to true. And therefore, the statement that follows will execute. And notice there are curly brackets here. Right. Now, this could be one statement. It could be multiple statements. Now, they ask the question, what if the grade is 5? So if this changed to 5, if 5 is greater than or equal to 9, would evaluate to false, obviously, right? So that would be false. And this code here would be skipped over. We wouldn't execute that code. All right. Notice it also says the Boolean expression must go inside parentheses next to the keyword if. I do see people leaving a space here. I also see people touching them together. It's kind of a preference thing. For an if statement in C#, I usually separate them, by the way. Let's do a little practice with this. There's a kind of a challenge slide here. And so I'm going to pull my Visual Studio over and start coding this. But let's read through it first. It says, create a console program to average 3 values. For this program, we will ask the user for the number of calories consumed on 3 consecutive days, declare 3 integers, value 1, value 2, value 3, prompt the user to enter these values, and then print out the total average with the average print high if above 2,500 and low if below. So there is a question being asked, and there's also a recommended output format for this. So I'm going to code this one and bring it over, and I'm kind of going to like split my screen here just a little bit so we can kind of look at both at the same time. And that's not where I want it to be. We want to be here. All right. All right. So help to guide me. What should I type first? If you guys are thinking console right line, I think that sounds about right to me. And is that what I'm doing? I'm prompting the user though. Should I be doing a right line? It's okay to unmute and just answer, by the way.
Shouldn't it be console.write? Or console.readline? That's what it is.
Yeah, I think that's a better choice. Since we're getting input from the user, absolutely. Now, what we're typing in here in the double quotes is what we're prompting the user to do. And we want them to type this in. So we want them to enter calories on day 1, right? Isn't that kind of how it goes? And then I'm leaving a space there. Now I'm doing this read line thing, but whenever I'm grabbing something from the user, and I should store it right away, right? And this is something we talked about last week too. So what kind of values should we expect here?
Numeric.
Okay, I agree. All right, and John, what type of numeric value do you think we should expect?
An int.
An integer is logical, right? I don't think anybody's going to say, hey, I consumed 1,200.007 calories today, because nobody's counting those, right? Like that. So an int makes a lot of sense. So we're going to say int. We're going to say, how about cal1? That sounds pretty good to me. Equals console readline. Will this work? Will this prompt the user and store the value at the same time? Don't all rush to answer at the same time. I'm looking for a little interactivity here.
Yes.
Yes, thank you. Thank you, Alex1. Yes, this will work. And this is considered one of the more efficient ways to do it. Do I need to do any conversions?
If you're averaging, you might need to.
Okay. I might. Is this the place to do it? Yeah, so you're kind of thinking like me now, right? But really, the calories is going to be an integer. Let's just leave it as an integer. Now, we're going to ask this 3 times, right? So yeah, let's copy paste. And I forgot to copy. Oops. And all I'm going to do here is just change the variable name and the prompt. And really that doesn't look very good. So, and you know, if they don't tell us what okay, calories day 1. Okay, so they have a certain way of doing it. So when you guys are doing a lab exercise, you should try to follow what's being asked. So I guess if I was to be a good student, I would do something like this. right? If I want it to be just like what's expected. Now, it is really weird. I will tell you that when you're working professionally writing code and you're working with a client, whether it's an internal or external client, um, sometimes people get really particular about how they want stuff to operate in a program or a website or an app. So hey, if we're being asked to give it a certain way, I'm going to provide it exactly that way. Right, so there's my 3 prompts feeding 3 variables. All right, now to calculate an average, we do need to total up some numbers, correct? So let's come up with another variable. If we total 3 integers, it will add up to an integer, by the way, and we can just call that total. We can call it sum. And what would that look like? I think that's a pretty easy one, right? And I'll drop in that semicolon. So far, so good? Okay. Could I have determined the average right off the bat? I could have, right? But you know what? In this case, we want to create a variable for average. Now, does this need to be a different data type? I have people shaking their heads, right? If I typed in for these numbers 1 calorie, 2 calorie, and 3 calories, what's their average? Should be really easy answer, 2, right? What if I put in 1, 2, and 4? Well, now it's not an even number. Do I need to make the average a different data type? So there's a lot of answers to this, and I want you to think about this really carefully. If I had a decimal answer to this, would that be significant? I am noticing on the output here that it looks like they're including the decimal answer. So probably we want that. So what kind of value should I use here? What kind of variable should I declare for average? Feel free to unmute and offer up. Okay. Thank you, Mr. Sanders. A double is a really wise choice, I think. And that's kind of the go-to. And then I'm going to put average. And then how do I determine the average? Well, I will take that total and divide by what? Don't all rush to give me the answer at once. And then we need to do output, correct? And once again, we could, mimic, what's here. In fact, I'm just going to copy this. I'm not going to output that number, obviously, but I'm going to copy the words just to save myself a little bit of typing. And then when I get into this, isn't that interesting? It brought over the carriage return and the new line character from, oh, interesting. And, oh wait, low is going to be an optional thing, right? So I'm going to actually leave a placeholder there. So I've kind of sort of pre-built my output statement. And in this spot here, what do I want to place? The average, right? The average calories. Some of you use string interpolation. Coach me on how to do string interpolation. What's the magic character key I have to put before it? Not hearing you, Curly. I know you're saying it. You got like a software switch in your microphone? A few of you did this, so I know you know how to do it. So somebody coach me. So I got dollar signs. Is that correct? Dollar sign?
Yeah.
And then what do I do? curly brackets? Is it, am I lip reading correctly? And then what goes inside here? What do you think? Is this correct?
You want to put that $sign in front of the first double quotes.
Ah, okay. So you're following me down the incorrect path. All right, thank you, Alex. So that tells us that we're going to use string interpolation, and then we're allowed to use it inside the statement. We're going to use it here also, correct? So we might want to have some sort of a message here. You know what? Actually, this output message might happen, now that I'm thinking about it, this might happen inside our if statement. So let's get to the if statement finally. Here's the if. If, what do we check? What are the criteria? All right. Print out total. Oh, we got to print out the total and the average. So I guess we'll have to do both of those. With the average, print high if above 2,500 and if low, if below. Okay. So why don't we do this? Let's print out the total number of calories. Let's copy this statement here. I'm trying to find like some efficiencies here. And you know what? That can actually happen before the if statement. So we could say the total number of calories per day is and let's put a period there too. Now let's do our if statement, and we're going to say if average, and what's my criteria? The criteria once again is if it's above 2,500. So let's try to code that. Visual Studio keeps popping away. So if the average is greater than 2,500, if that's true, put in my curly brackets, we are going to output perhaps this. I deleted some of the extra components there. And then, we haven't learned how to do else statements yet, by the way, we're going to write a separate statement saying if the average, I'm just looking at the criteria, if it's above 2,500 or below, what if it's 2,500? They didn't say anything about that, did they? Am I correct? So 2,500 must be perfect. So if you get 2,500 calories, you're perfect. But if it's above 2,500, it's high. If it's below, it's low. They're not even thinking about the 2,500, are they? Right? This is the kind of thing that you start spotting as a programmer. You know, because really I would say like 2,500 greater than or equal to, as opposed to, you know, but they're not saying that here. So I'm not coding it that way. Right? So then I'm going to say if the average is less than 2,500, then I'll paste that right line back in, and we'll say low. Let's go ahead and run this. So here's all the completed code. Here's an example. Hit the run button. Here comes the console. Oh, we got build errors. What am I doing wrong?
You're not converting.
Okay. And it says, okay, so we're running into the nullable thing. Do you guys remember how to solve the nullable problem? Yeah, there was a special character we use. because what the situation is, what if, and actually I'm putting it in the wrong spot, aren't I? What if they don't type anything, right? That's a consideration. Is that the right spot? Well, if that's the right spot, then why am I still getting an error? You guys remember this from last time? This is my test to see if you remember the content from last week. Somebody
Doesn't it have to go after the variable?
say that again, John.
Doesn't it have to go after the variables after Cal 1, Cal 2, and Cal 3?
Okay, so John is saying we should do this. Is that the right character? Well, now the read line error has gone away. But then I have this right underlined that says local variable int cal1. What would be a fix for this? You guys, you remember when we did this last week, or was it too late at night and we did it too fast? Yes, we did it. We did it a little too fast, but there is a stipulation here when we're dealing with these, right? They're expecting, and notice here, it says they're expecting a semicolon, but the semicolon's here. Why? Could I solve this problem in a different way? There's a few different ways we could solve it. I'm going to show you the old school way. This is the old school way to solve it. I would declare it here and preset it to 0 would be one way to solve the problem. And then in that case, I don't need to worry about that at all. Right. Here, I don't need to redeclare it. And I'm just giving you that as the one example of one way to fix it. Now it's still giving me an underline. So how do I fix it then? Look at the fix it's giving me now. It wants me to put in all the old-fashioned namespace and class statements to fix it. And look at the fixes it's providing. Are these correct? You guys are all drawing a blank on it, and I think it's kind of interesting. Nobody remembers this from last week? All right. How about I do this? Because we're a good way into the class right now. I'm going to take a 5-minute break right now, and I'm going to leave this question hanging on the table, and I want to see who comes up with the correct solution. Right? What would be a fix for this? If you want, you could type the solution into the chat. I am going to do a really quick little breakout room now. I'm going to pause it. All right, so we took a little bit of a break, and I kind of put that challenge question out there to everybody. And here's a really important concept. Whenever we are grabbing input from the user at the command line, and whenever we are putting information out to the console, it always travels as text. So if I prompt a user to enter their calories per day, it's not coming in as an integer. Therefore, no matter what I do, I cannot store it in an integer because it is text. That is really the question. Now, what's really happening, and I'm going to do a little bit of commenting here to kind of work around these issues for the moment. Right. And of course, you comment out one thing and it generates other problems, but what's really happening here is when we're reading this in, this is coming in as a string. Now, still a problem with the read line being null. So the question mark would go here for the read line, right? That's where we would put it to try to cancel out that, right? And it's a capital, sorry, to get rid of that. Now, the interesting thing that happens though is that we're still contending with a conversion. So we can convert in a number of different ways. We can grab it as a string and then convert. We can do the conversion in advance. And I know that some of you, contended with this in your exercises. So what I'm looking for is the brilliant inspiration from somebody. What would be the best way for me to proceed here?
I think it would be leave it as an int and then put convert to int 32 before the console dot read line.
So you're saying do this, convert to int 32 here, like this, or is it a function and I put parentheses around it?
Yep, and then you would put it inside the parentheses, and then convert with a dot at the end.
Folks, what do you think? Doesn't seem to be working either.
That's because you got to put convert and then dot.
Ah, okay. Convert. Now am I good? The convert statement's correct now. Visual Studio certainly likes it. It certainly doesn't like my read line though. And you notice the suggestion it's providing. Is that something to worry about? Is that a critical failure here? You guys are a real talkative bunch, aren't you? So you guys did this all over your homework. So I'm looking for that grand inspiration. What's my way to proceed?
If you, sorry.
It's right on the tip of your tongue, I can tell.
Basically, if the int call like to int like is true, basically it just tests if the user input can be classified as an int. So then you have to like say, if so, store as an integer or whatever kind of variable.
Yeah, so you're actually wanting to put this into an if statement here, right? Could we try a different approach? Could we do the thing that they're suggesting, which is string question mark, do the read line, I'm going to call it something else just so we don't get a conflict. Could we do this? Oops. It doesn't seem to like that very much either. Somebody has to have the brilliant inspiration.
This may not be the solution you're looking for, but if you do a console.write and put your text like calorie day one for the user to input, and then do declare the variable with a console.readline, don't put any text in the parentheses, you shouldn't get that error.
Now, Mr. Sanders, I appreciate that you have Mr. Sanders there. I appreciate it. Drop this into the chat. And Alex, this is kind of along the same line. Oh, let's see, my copy paste is not cooperating here. All right. Put this in the chat. This is what you're talking about, right? We do a console write line. So we just output. And then we convert to antenna. Yes, this is the approach I was looking for. Right.
And if you want the input to just be at the end of that text, instead of write line, just do write.
Right. Yeah, that's actually a good point. Right. So that the prompt, so in other words, the cursor will flash here as opposed to the line below. I'll tell you what, let's just rename our variable here. So I'll call this cal1. I'm going to kind of get rid of this stuff here. We don't need to do a conversion now, do we? Because the conversion is happening in the second statement. So we're putting it on the screen. They're typing in a value. We're grabbing it, converting it to an integer, and storing it here. So now the process is repetitive. You guys recall this stuff at all? How many of you did your homework like this in this fashion? I think yeah, a lot of you did. All right. And this is probably the way that I would shoot for, just from the standpoint of comfort, kind of like really the old school way to do it. And so we're prompting, we're grabbing, we're storing, right? And you know what? Let's add here, enter second number, enter third number. And really, you know, is that what we're supposed to enter? Enter calories day one. Right. If we're getting persnickety about it, right? And, you know, I think it's important to be accurate. So these are just, you know, clever little workarounds here. I think this looks pretty good. No errors, so this would run. Should I go ahead and run it? Is this enough to make it work? Do I have everything I need? Right. I hope your answer is yes. You know, I think all of our logic is sound. I think our math is okay. I think our inputs are now okay. All right, so I'm going to go ahead and hit the run button. Let's see what happens. Okay, there comes our run. And I'm moving this over to the side here so we can still see the code. So enter calories day one. I think we were given some examples right in the PowerPoint. 2, 3, 4, 5, 31, 22, and 1995. And I'm assuming that number is accurate relative to that. So let's see if we can just pull the console up here and type those numbers in. I got 2, 3, 4, 5, 31, 22, and 1995. Or assuming these were numbers that they ran. So I pressed enter, and I come up with 7462, and my output is the average number of calories per day is 2487, which is low. Are you guys noticing that I'm not getting the decimals? Is that okay? Are we having a hiccup with the internet here or something? Are you guys like, is it kind of choppy a little bit?
No, it's not. The internet's fine. The answer is not correct. We want 4 decimal places.
We do. Okay, so then what's happening here that's causing that? I'm trying to get back to Visual Studio here, which is fighting me a little bit.
I think you're not supposed to use int. You're supposed to use like float or double.
Okay. So if I made total a double, would that work? Or would I be able to maybe very simply do something like this? Would that make it work? I don't know if you guys are thinking like I'm thinking on this. Do you guys remember the part about casting? Whereas if I mix the data types, so this is kind of this is a real primitive hack, by the way, but it does work. It should work. So I'm gonna run this. The program is still running in my console here, so I'm gonna terminate it. Let's go back and relaunch it. My machine feels very sluggish right now for some reason. I'm not really sure why. I'm going to assume it's Zoom. All right, can somebody read those numbers to me again off that slide? You have them handy?
2345, 3122, and 1995.
Okay. Well, now I got way more decimal places than I ever bargained for. Now we could worry about formatting this, and you know what? If you remember, we did have slides all about formatting and how many digits we're going to show. I'm not really too worried about that. I'm really kind of trying to demonstrate the key concepts here. Really, the focus is on the if statement, but we're also kind of refreshing all of our module 1 skills if you're picking up on that. And that's okay. That comes with practice, folks. And whenever you're working with a language, especially when it's new, every language has its nuances, and so do the tools that you're using to build that language in code. I'm going to call this a success. It is working correctly. My only contention with this prompt is that they're saying if above and if below, and that's actually misspelled, right? If below, right, is what that said. If below, but they're not talking about what if it lands right on that number. They're not talking about that at all. I see that as a flaw as a programmer, and hopefully I get your brains to start to think like that too, where you're noticing little nuances like that. All right, let's go back into the flow of the topic now, and they're talking about the semicolon and the curly brackets here, and they're showing you the layout of how Microsoft prefers that we do an if statement, right? And so generally, if the parentheses, the Boolean expression, your curly brackets, your statements inside, semicolon after each statement, but the if statement, at least on the first line, does not get a semicolon there. The thing that is really weird about this, if you did type a semicolon there, you won't necessarily generate an error message. It'll compile, and this code will run too, but not relative to the if. It'll just run. And that's a little frustrating and weird, but you have to be mindful of that. The if statement really is terminated by that closing curly bracket, not by a semicolon. That's a little bit of a change from what we've seen. And the reason for that is whenever we're using curly brackets in code, we're establishing a block of code that begins and ends, regardless if it's an if statement or anything else. Now, if we do run an if statement and we have multiple things that happen inside of it, that's also allowable. And the curly brackets help to show that when this evaluates to true, that everything inside the curly brackets will execute. So all 3 of these statements will execute because they immediately follow the if. There's kind of a weird kind of approach here, and we will call this a flag, when we're looking at values, that sometimes when we are looking to determine if, this is a really good example, I think, where we're trying to figure out if a student is good or bad, good student, true or false, but we're presetting it to false because we're not going to assume that you're coming into school and you're already a good student. I'm not sure if that's really a good assumption, but, for the sake of example, right? So if you get a grade over 95, then certainly you are a good student. We set that to true. Sometimes it's common, and when we preset a value in hopes of possibly flipping it, we'll call that a flag value. That flagged value can also be used to trigger a statement to just run. This is kind of an interesting thought. So if I take a Boolean value and set it to true, and then I just put that value right into the if statement, I'm not checking anything. What's the value of good student? True. That's what if is looking for to run, correct? And so the statement would run. So you can also, as the result of other programmatic things that are happening, switch the status of it or force something to happen. Now, if you're forcing it to happen, then why do you have the if in the first place? So the thought would be that something else is happening up above that will trigger this to be true or false. and then it will react to that directly. Another kind of interesting thing, when we're doing if statements and we're looking at individual characters, I don't know if you guys remember, we were talking about kind of like the numeric codes that go with all the letters and symbols on the keyboard last time. And basically, we have this little link here, but you can follow that if you wish. But when you're looking at letters and we do a comparison to them, so like in this case, we're looking at comparing the letter F to see if it's greater than the letter E. And numerically, by the way, the numbers that sit behind in that Unicode table of the letter F is a greater value than the letter E, capital F and capital E, right? And therefore, this statement would evaluate to true. So we can actually compare individual characters, and only because they actually translate to numeric values on the back end. And that's kind of an interesting thing. Now, this is an interesting thing to note, and I say this because it's a stylistic issue. You notice that when I type my if statements inside of Visual Studio, and then I put in that first curly bracket, and Visual Studio automatically closes the curly bracket, it sets me up in this format. So if the if statement's on one line, the opening curly bracket is here, and the closing curly bracket is there. And real frankly, in most other languages, when we use curly brackets, we usually start the curly bracket right after the if statement for whatever reason. The Microsoft convention and preference, and their tools do it automatically, is to put you in this mode. Microsoft has this thought that this is easier to read than this. My practical experience, writing, frankly, more Java code than I've ever written C#, is I tend to write it the bottom way because I'm just more comfortable with it. Visual Studio did override that. I don't know if you noticed that. I didn't manually place my curly brackets in that spot. Visual Studio did that for me. And so I'm just letting the tool do it. If the tool does that, fine, I'm good with it. The one reason I do like the other approach better, frankly, is because it's a little more concise. It occupies slightly less visual space. So I tend to prefer that if I have control over it. If Visual Studio is changing it, we just go with it. Right, moving on to the next major topic here, we are going to look at the if-else statement. And from a flow charting or like process flow viewpoint, we'll still have a decision to make, right? So we have the same question we had before. Is it cold outside? It's either yes or no, true or false. If it's true, we wear a coat. If not, we put on sandals. So if this statement is true, we execute. Else, we take the opposite approach and we execute a different statement. And when we switch that over to code, it looks like this. Now we'll use the letter E and F example again. So if the letter F is greater than the letter E, which it is, right, then this statement will execute. If I happen to flip the sign here the other direction, notice there's no logical test that follows else. So if this letter was the capital, it was a D, is D greater than E? The answer would be false. So it would fail this test. This code would not execute. This code would execute automatically. There is no logical test for it. It just happens. So we're assuming, hey, it's cold outside, you put on a coat. Otherwise, I'm putting on my sandals, and that the sandals is just going to happen automatically because that's apparently your default state or something. But that's how these statements operate. So with an else, if the one action doesn't happen, the other one will happen. Right? And notice, and it's pointing out, the else doesn't have a Boolean expression. There's nothing to test. You don't have to test for the opposite condition. It's executed automatically. Right, so this is just a matter of logic. Here's another really weird feature. This is true, I think, in every curly brace based language, by the way, which makes it a little perplexing, right? If my if or my else only has one statement inside of it, I can omit the curly brackets. That's totally allowed, right? It's allowed in Java, it's allowed in C and C++ and C Sharp and JavaScript, by the way. But here's my recommendation: don't do it, because I'll tell you what happens when you do this. You'll start to write additional code. So you'll write this if statement. It's like, yeah, like, great, this works. This is awesome. And then you'll think of another statement that should come after this one, and then you wonder why it doesn't execute. And it's because you don't have the curly bracket. So once you go past one statement inside either an if or an else, then you have to have the curly braces. So here's my sage tip as a programmer for many years. Even if it's one statement, please just include the curly brackets, because it'll keep you from making mistakes in the future. Right? If you're trying to write really efficient code, yeah, that is much more concise, right? Because now we're, the way Microsoft does it, there would be 2 additional lines here and 2 additional lines there. We're saving 4 lines of code by doing it this way. So you see why they do it, right? And often when we do if else's, very often we do come up with singular statements that follow. But sometimes we don't. And then when we forget to have the curly brackets, you got a problem. And here's kind of an example. Like if I do this statement, no curly brackets, this one will execute with the if. And yeah, this one will always print. It doesn't matter that it's indented, right? So really what we're figuring out is that indent is done for our eyes, not for the engine that runs the programming language. The language is looking for curly brackets and semicolons. Our eye likes the indent because it's easier to read. But really, truthfully, this should be, all the way pushed to the margin, because it's not part of that if statement. So another reason, real strong reason why I think you should always include those curly brackets around those if statements, even if it's just one line. All right, let's take a look at a scenario, and we're going to start looking at an even slightly more complicated structure here, by the way, which is an if-else statement. And let's look at the scenario. We got a bank customer applying for a loan. To qualify, you have to meet 2 criteria. One is you have to have an income of $50K or better and at least 2 years at their current job. So you've been working your job for 2 years and you're making over $50K. How would the conversation go between the customer and the loan officer? That's our scenario. Well, here's a flow chart, right? So the guy would sit down and ask a question. Is your salary over 50,000? Yes or no? Right. Now think about this. If the answer is no, there's no reason to check the second criteria, right? Because both criteria have to be true in order for it to be a thing. So, okay, so if you have a salary over 50K and you're 2 years or more at your job, then you are qualified for the loan. Otherwise, you are disqualified. If you're under 50K, you're automatically disqualified. But this approach where we have one if statement that goes inside another if statement, the second if statement would be called a nested if statement. So it's nested inside the other. From a coding standpoint, right, here's the first if, right? So if the salary is over 50K, but what would go here is another if statement, right? So, and it says you can put one if statement or an if else statement inside the curly braces of another. The one inside will only be tested if the outside one is true. There's no limit to the depth of nesting. So as far as your brain can comprehend it, you can write the code. I will tell you from a functional limit, though, that a lot of us kind of overload once we go a couple, 2 or 3 levels deep logically. So that's where the flowcharts really, really help, right? And I'll tell you what, if you ever sit down and do your taxes, and you do them manually, like on paper, or these days most of us use like TurboTax or something, but in the old days, like reading through like the IRS's forms, like if you're over 50K and you're married and you have 3 children and you're single, or whatever, it's like if they've got all this stuff. I mean, they must have had some nerds working on that for years to figure out those tax laws, which is why I always say like simplifying them does make a lot of sense in many ways. But here's an example of taking that flow chart that we looked at up here and then applying it to code. So here's the first decision point. If the salary is over 50K, let's say it's false. All right, well, you're disqualified. Okay, but if it's over 50K and that's true, now we ask the second question. If you've been employed for 2 years or more, you're qualified. Otherwise, you're disqualified. This complete statement inside here is the nested if statement. All right. So kind of reinforcing this concept here, once again, about indentation, that's always done for our eyes, not the computer's eyes. The computer doesn't care at all. That formatting that we see inside of code is always for our benefit, never for the computer's benefit. When the computer processes all that information and breaks it down to an instruction set that it understands, none of that is included, by the way. C# really relies very heavily on those curly braces, the parentheses, the semicolons to structure all the statements. And it's basically what they're trying to tell you here is that we indent for a reason, right? So that we can see really clearly what code belongs with what. If you're mistakenly indenting, it can deceive you. And I think that like non-curly bracket approach is a really good example of that. So be careful of that. And you know what? If you happen to write code where you're not indenting anything, right? This won't happen in Visual Studio, by the way. Visual Studio will automatically format it most of the time. But if you're writing in another tool where you can write everything to the margin, the engine doesn't really care. So if you wrote this statement, think about this. If salary is 50,000, all right, then what happens? Well, it's not really clear, right? Then you ask another if statement. And what they're trying to tell you here is the statement that comes immediately after an if is included in the if with it, and then the else as well. So like these 4 constitute one solid statement. Weirdly, this whole statement is or seemingly should be part of this if statement, but it is missing the curly brackets. So the only part of this that would really process is the else. There's no true part of this statement because this statement is complex and requires curly brackets around it to be part of the true part of the first if you guys are catching my drift here. So you got to be, indent and use curly brackets to keep the stuff organized. Otherwise, you kind of can't predict the outcome real easily, especially when it gets complicated. Right. All right. So here's kind of a thought that they throw in here. It says when the options are mutually exclusive, you can use an if, else, if statement, right? And so the example is a number grade will only ever match one letter grade. Once you found the match, you don't need to check the other option. So check out this little chart here. And this is, sort of how we do your grading in a sense, right? So if I'm checking a student's score, if that score is under 60, well, that's an F. So if it's true, that's an F. You branch out and bypass. But if it's not true, we might ask an additional if statement, right? So we follow the false branch, and in this case, we would say else if the score is under 70, we would get a D. Else if it's under 80, you get a C. Under 90, you get a B. Obviously, if it's above 90, you get an A of some sort. That can be converted to code also. And you'll notice the code version of this and how it's written. And the flow chart that we just saw matches this. So we check to see if this is true. And if it's not, then we check to see if this is true. And if it's not, we just keep going down the line until we find. And what's unique about this type of an approach is you can check multiple conditions, often over a range, to find the right value for a score. And this is, a process that we do all the time. As a teacher, I've kind of got like grading scales are kind of memorized in my head because I use them so often. And I never think about the logic of how that works. I just look at the score and go, oh, that's a B, But truthfully, somewhere in the back of my brain is doing this, right? And if we want to process a score numerically in a piece of software and convert it to a grade, this is a logical piece of code to do so. All right, we got another little challenge thing here, so let's try this. And this is a try it out exercise, and it says write an else if statement that evaluates the temperature and prints a reaction. It should provide at least 3 responses. For example, way too cold, a little chilly, good hiking weather, that's it, I'm moving. Right. So this is like the Wisconsin conundrum. Now you could look at the grade thing as an example, but you might want to think about like these answers and how you might order them. All right. So if I'm just to write a straight up if statement, I'm not going to write a whole working program here, but let's go ahead and write a simple little if statement. So what could be criteria I could check? So for example, I could have maybe an integer that's the temperature, and I could preset it to a value, right? Or I could prompt the user for a value, whatever. But let's just put in kind of a moderate temperature of like 70 degrees. Now I could say if the temp, do I go less than or greater than? Right, well, they said it's way too chilly. All right, so maybe I could say if the temperature is less than, like, what's your cutoff in Wisconsin? I know, like we're pretty hardy folks here, right? Like, what's the lowest temperature you'd ever deal with here? All right, I remember like the coldest day I've ever experienced in Wisconsin, in Milwaukee, or up north is different, right? I think it was minus 26. And it was a weekend, so I went out, of course, and this is as a youth. I do recall the day very, very well because I remember my friend had just taken a shower and came to meet up with us, and his hair froze when he walked from his house, which is 2 blocks away. So in 2 blocks, his hair froze on his head to a shape. It was very amusing, by the way. All right, so if the temperature is under minus 26, I might have something like, so you can have a little message here. A lot of Wisconsin people say, that's it, I'm moving to Florida. Is that your drop dead temperature? I'm not sure. Then you could do else if the temp is less than 10 degrees. Maybe that's a good point. You might console right line. Let's go ice fishing. Right? Do a positive activity, not a negative one. And I'm just going to keep on going with the example here. Else if, let's say the temp is, let's say less than 40. Or how about less than 60? what would we say here? Good working weather. If you're doing stuff that takes physical activity, that's a good temperature to be under to work so you don't sweat, basically. And maybe our else, anything above 60, we might, we're not even going to test the condition. We're just going to say something like, temperature will say, it's beautiful. And that's kind of my temperature limit. Like 60 degrees is where I start putting jackets on, otherwise I'm like, it's perfect. Now I could put in a stipulation too. If it's like over 90, I could say it's miserable, right? That would be a condition too. And so I could maybe add that here. And the point of an exercise like this is just to get you thinking about like how you set up the criteria. So I'm going to say if it's over 90, we haven't learned about compound statements yet, but I know those are coming. So just a very quick example. These are very common, like, and you think of scenarios where we don't want people, if like one scenario doesn't hit, to just opt out or, have like the branch of the programming is done. We really want to kind of address the whole gambit. So regardless of what temperature it is, I have a scenario in place to address it. And yeah, 90 is kind of, like where I start going, yeah, this is hot, and I don't like it, anything below that I can usually live with. But if it's over 90, it's like turn on that AC and get me out of the sun, give me a nice cool beverage, right? But these are the types of scenarios that you might encounter. So learning how to build these, I think, is really important because it will be important for your homework, by the way. I'm going to keep plowing forward. And I think that what will be really helpful for us, and I don't know if I'll finish off the slides tonight. I think I should be able to. So I'm kind of leaning towards my early option rather than my later option, which is I think I'm going to go through all the material. And then when we get together on Thursday, we will spend a majority of our time coding together. And I hope that that works for everybody because I know some people are also a little behind on things. But I think that there's a lot of value in doing collaborative coding, even if it's kind of sort of giving you the answers to the homework. Of course, you are welcome to work ahead, by the way. All right, so let's look at this. Logical operators, and this is where we get kind of, things get a little fuzzy for some people because we start asking logical questions and we have to understand how logic works first. So for example, I'll go back to my ordering pizza thing. All right, so if I have more than $20 in my pocket and the Packers are playing tonight, I'm going to order pizza. Else, I'm going to make mac and cheese. But okay, so think about how I asked that question. So what if I had $20 in my pocket, but the Packers weren't playing tonight on TV? Would that be true then? Would I order pizza? Yeah.
No, you're eating mac and cheese.
Yeah, I'm eating mac and cheese, right? Because why would I order a pizza if the Packers aren't playing? Right. Because both have to be true. So here, look at their recipe says, the cake recipe says I need water and eggs. I have water, but no eggs. Can I make cake? No. I have eggs, but no water. Can I make the cake? No, right? If I have neither, no. If I have both, yes, right? So when you use the and, both things must be true in order for the statement to resolve to true. And that's what we're really learning here. So the logical and in programming is expressed with two ampersands put next to each other. This is kind of a programming universal, by the way. Just about every language uses this convention. So we put two ampersands together, and what it tells us is that it's a logical and. And what it does is allows us to evaluate two separate Boolean expressions, both of which must resolve to true in order for the whole statement to be true. Okay. If you want to look at it in the form of a chart, do I have water, true or false? Or do I have eggs, true or false? The only situation in which the truth basically intersects, right? I have water, that's true. I have eggs, that's true. So true, I can make cake. Both conditions must be true. If either one is false, the statement is false. Okay. And I think the eggs and water are a good example. All right. Now the cake recipe also says I either need to have oil or applesauce. I don't know if you guys know that about cake recipes, but that's an acceptable substitution for cake. Like if you, hey, you need to use half a cup of vegetable oil. Oh, darn, I don't have any. Oh, but I have some applesauce. That is considered okay, by the way. Now, if I was out of oil, I would just use butter personally. But okay, let's say you don't have oil or butter, but an or has a different implication. The or says, and think about this. If I have oil but no applesauce, can I make the cake? Yes. If I have applesauce but no oil, can I make the cake? Yes. If I have neither, well, no, right? If I have both, well, then I have to pick one, but yes, I can make the cake, right? So the logical or is represented by these two up and down lines. And if you look on your keyboard, right above your enter key, there's the backslash key, and the shift of the backslash key is that vertical line, which we call a pipe, by the way. Some keyboards will show it as kind of like two separated little lines, but it really is one line, and those are called a pipe. Two together forms a logical or. And the way that the or works is basically only one of the expressions needs to be true in order for the whole expression to resolve to true. Right? I'm trying to think of a good example. If I have more than $20, or if the Packers are playing, I will order pizza. I don't have $20, but the Packers are playing. Well, I don't know how I'm going to pay for it, but we'll use my wife's credit card, I guess. Yeah, we're going to order pizza. So that's a very bad example, not a very good one. That one's also laid out in a little truth chart here. And notice the difference, right? Because you only need one of them to be true. And so the likelihood that it's going to be true is much higher, right? In terms of just sheer percentages. But if both are false, then it absolutely is false. But only one needs to be true in order for it to evaluate to true. Let's go back to that loan example, right? So our bank customer needed, and this is kind of where we're leading to, a $50,000 salary and 2 years on the job to be qualified. Remember how we did this before? We took one if statement and we nested it inside the other. So we asked an if statement. Okay, that was true. Then we went to the next if statement and asked that. And then if that was true, we did the action, right? Now in this scenario, since I'm kind of like two ifs in a row, technically, I can combine them into the one statement with the logical and I can ask both questions at once if both need to be true. So I can say salary greater than or equal to 50, or, excuse me, and the years are greater than or equal to 2. So if both of those things are true, the person is qualified. Otherwise, they are disqualified. So you can see one advantage of using a compound statement like this is the fact that you can write a whole lot less code and get to the same spot. Now, some people will also ask this question, well, can I limit this to 2 statements, or could I say if salary greater than 50,000 and years on the job is greater than 2 and they're married, maybe, if all of those are true, we'll give them a loan. Yes, you can do that. And in fact, what happens is there's kind of like a feasible limit to those in terms of like how your brain can process it when you're writing it. So it might be easier to actually break them into separate statements, but if you can conceptualize it and the logic is correct, there's no reason why it wouldn't work. And you can keep going with how long those are. Let's look at the converse example of the or, right? And it says, for fish to thrive, the water temperature for tropical fish, right, should be between 72 and 80 degrees, right, within a very warm water range. And so look at how this is expressed, and this is a real classic example. So if the temperature is less than 72 or the temperature is greater than 80, do you notice that we're trying to really say that we're trying to fit it in the range, but instead of flipping the signs, and going the other direction, we're looking at stuff that's outside the range, right? The range that we're looking for is 72 to 80. But if it's above 80, if that's true, right, the statement is true. Or if it's below 72, the statement is true. Now, if you think about this really carefully, I couldn't flip the signs on this because that wouldn't work from a logical standpoint. You have to stop for a moment and think about it, right? So if the temperature was greater than 72 and the temperature was less than 80, and I automatically set it, right? Then it switches to an and. Do you see the difference? So both could conceptually work. And if I was to write this, by the way, as an and, it would be temp greater than or equal to 72 and temp less than or equal to 80. So the signs flip and equals included. So that's a real classic programming problem when you're given kind of like a range like this, that the or kind of pushes things to the outside of the range where the ands look at the inclusive part of the range. And you can re-engineer your logic with the words if you flip your signs, right? And so that also takes a little bit of practice to recognize, but this real classic programming technique here being demonstrated. The inclusive thing, right? And these are not related values. This is salary and this is years. But here, where we're checking basically the same value, we're trying to force it in a range. We're looking to see if the outliers are, true. In which case, danger, right? So if over 80 or under 72, the fish are at risk of dying. Otherwise, it's right in that range. It's just right. And that is really kind of the difference between the ands and the ors and how they operate. Now, there is also the logical not, and this is also a little strange because here comes that exclamation point again. And here, instead of being placed with an equal sign, so instead of saying not equal, when we place that symbol, the exclamation sign, in front of some value that evaluates to true or false, we are negating the statement. So in other words, if I have a Boolean variable called valid and it's set to true here, and I want to check for its inverse state, I would say if not valid, right, or not true, then we'll say try again. Or if, okay, the temperature is less than 32, if we're negating it, what are we really saying? It's greater than 32. It's not less than 32, so it must be greater than 32. And really, truthfully, greater than or equal, if you think about it, right? Equal would be included there. And that's like why, like when we did that other problem in the 2500 didn't get talked about. I recognize that as a programmer because it's a classic problem, right? So not less than 32 is the same as saying 32 or greater. Now, Why would you use negation? Because sometimes you have information that's presented to you in a certain way, and rather than write new variables, it's just simpler to check the inverse state. And I think that's really interesting. Here, we're negating something that's already a true or false. Here, we're negating something that resolves to true or false. Right. If I didn't have the parentheses on this one, it would be checking the inverse of temp, which wouldn't make sense, by the way, because temp apparently is an integer. It's not true or false, right? See the difference? You know, so I think that's a really helpful thing to think about also. There is kind of a precedence in these things, by the way. Like if you have multiple declarations of logical operators in one statement, so this does happen. So we might say not valid, and pizza money is greater than 20, or Green Bay Packers are playing. Right. The order in which we process those, there is a precedence. Not goes first, and goes second, and then we check the ors. Now, why? Because this once again stems from math. That there isn't a precedence in mathematics, so that precedence transfers over to most programming languages as well. Programming is always very, very tightly tied with mathematics. Unfortunately or fortunately, depending on your viewpoint. All right. So if we take a look at this little slide, I think this will help you maybe see what I'm talking about. So I need water, eggs, and oil, or applesauce to make my cake. So if I have water, okay, that's true. And I have eggs, that's true. And oil, that's true. Or applesauce, well, the way that we're processing this, if you look at the chart, is we do not, and then or. So true, 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 true. Right? All of these are true. So true, false. Why is that one false? Maybe it's because of the number of eggs we need. Maybe we need 3 eggs. I'm not sure why that's it. But all of these are evaluating to true. Is this a true statement then? For this, would this be a true statement? No. The ands dictate that that must be true. I see it as being true. I'm not sure how many eggs you need. If you need 6 eggs or 4 eggs, well, yeah, that would be an issue. Another thing that is very helpful, by the way, is if you are evaluating something where the or, like we know that the oil and the applesauce are kind of interchangeable, it's helpful to put parentheses around them. So those evaluate as one true false statement. In this case, this would evaluate to true. And so we'd have a true and false and true. And the grand result would still be false, assuming that that's not enough eggs. That's kind of a weird little example, but it is what it is. Now, another thing that happens in programming quite a bit, and this happens especially when we're interacting with users or processing text and data, is sometimes we will look at strings and comparing them. So for example, if I'm looking to see if your name is equivalent to my name, and what are we really checking? That it's exactly the same letters, exactly the same case, right? So if I had 2 Alexes in a class, does Alex equal Alex? And really, I want you to try to remember to do this. Is Alex equivalent to Alex? Because whenever we see the single equal sign, remember it's an assignment statement. It's for storing variables. The double really means equivalency. So if Alex is equal to Alex, we'll write the same. But if Alex is Alex equivalent to Alexander, would that be true or false? False. right? So when you're comparing a string, it's got to be exactly the same letters and exactly the same case for them to be equivalent. Now, there is also a method that we can use, or function, if you want to look at it that way, where we can take name 1 and see if it equals name 2. And guess what that does? By the way, it does this in the background. But it does it in the form of a function. So this works too. These are functionally equivalent statements. So if this was Alex and this was Alex, name 1, Alex equals Alex, yes. Alex equals Alexander, false. Right. So we can test strings. You can also test for the inverse. So I could say if Alex does not equal Alexander, is that true? Yeah, you have to stop and think about those for a second. Whenever you throw the not word in there, that is true. If Alex does not equal Alexander, totally true, then not the same. You can also do the same thing with that equals function, but notice I can take the inverse of one of them and see if it equals the other. That's also the same logic. I will tell you it's a little bit of a mind bender though, and a lot of people kind of fumble a little bit when it comes to negation, just like they do with regular language. But you have to think about it when you code that, and think about the scenario. And maybe like sketching it out on paper is not a bad way to go to try to figure out if that's true or not. It's all about kind of thinking about it and listening. Now there is kind of another weird scenario here. Now, when we were looking at characters, we were looking at the letters E and F, and that we could use the greater than symbol. And it works with characters because characters are represented as numbers kind of in the background of all this programming stuff. But if I take a whole string, like, a name, I cannot do this logical test of is name 1 greater than name 2? Does not compute, basically, is the answer to that. The compiler will kick it back. However, there is a compare function, right, that we can use, and method they're calling it, and we can just drop it in like this. So we can say string dot compare, put in the 2 values, and that will check to see if they're both the same. Now, this is a method, right, as opposed to a logical operation. But we often develop methods basically to do these types of comparisons to see if they're the same. Now, what this returns, this is bizarre, it's going to return an integer. What do you suppose it returns? And why an integer? What do you think the possible return values for this would be? Well, I'm just going to clue you in. 1 and 0 are the return values, 1 being true, 0 being false. I don't know why it just doesn't return a Boolean, but that's how they did it in programming. The same thing happens in the Java programming language too. I always found it really fascinating why they opted for numbers. There must be a reason for it. I'm not really sure what that reason is. All right, getting to the end here, folks. All right, so this is kind of interesting. Okay, so it's not just 1 and 0. Apparently it's -1, negative or +1 and 0. So if the result is negative, name 1 is less than, comes before name 2. If the result is positive, name 1 is greater, comes after name 2. And if it's 0, they're the same. Interesting. Okay, so this works a little bit differently than the Java version, but a very interesting result. So why they're using negative and positive numbers, then you can flag on those and then run additional code. So you can compare 2 names, and then you could write code. If it's -1, then you can give this message. If it's positive, you give this message. If it's 0, you can give this message. That might be, for example, something you might see in an exercise, right? Yeah. And they're making the point here, it doesn't matter what the value of the result is, only the sign. And so this implies to me, I know that in Java, when this happens, they use 1 and 0 as the numbers. It implies to me that in C# they might use other values, and I'm not sure how those are calculated. They keep on going with this compare method, by the way, and talking about how it works. So, like, if you did do a comparison of two strings, you might write some code like this, right? So I can run the comparison as a function. So I put in the two values here, whether they're hard coded or variables. That will retain a numeric result. Then we check the numeric result. If it's less than 0, it's negative. So that means name 1 comes first and then name 2 alphabetically. If it's greater than 0 or positive, name 1 comes after name 2. They're flipped. So you could say name 2 before name 1. Same difference, right? Otherwise, if it's a 0, it's exactly equivalent to 0. They are the same. Right. So this is a handy little piece of code, by the way. And then they start talking about how strings are compared, and there's the mechanics that come behind it. So if I were to put in Mark and Mary, and think about this is how we alphabetize folks, right? This is how we learned how to do it. You look at the first character, the second character, third character, they're all the same, right? You know, they're kind of equivalent. Then we get to that fourth character, K comes before Y. So Mark is less than Mary because it comes before. Now, that's also because the character K comes before the character Y, and look at their numeric values. Interesting. So in programming, often when we're sorting things, we have to switch things to numbers to make the sort work, right? Whereas if we're human beings and we know that A comes before B, we can just look at it and go, oh, A comes before B. We don't think about the mechanism that it takes to figure that out. And truly the mechanism in our head is we memorized it as kids, right? We memorized the alphabet, right? And computers don't work that way. Computers work entirely with numbers. The other kind of interesting thing is if you're comparing something like this and we have different length strings, which one would come first alphabetically? Right. And if you're not sure, look in the dictionary. Does the word hi, like the hello hi, come before the other hi, which is up here, you know? Yeah, hi comes before hi. It has less letters. The first two letters are the same, but from a logical standpoint, this one comes first. Right. Now we are finished with the PowerPoint here. So what I'm going to do is I am going to pause the recording for right now.